In this lecture, we move to implementing shared object stores, and in particular, shared memory, where we want to implement a shared memory system in a distributed system, a system that only communicates through message passing. And we want to have a fault-tolerant implementation. First, let us consider real shared memory. So what would be a formal model of shared memory? We have no message passing. We only have a set of clients or processes communicating with the shared memory, so there are no channels. Processes do not send and deliver messages in this system. Instead, processes access the shared memory, and this models multiprocessors and multi-core system. And in this lecture, we are interested in distributed systems, and in particular, we want to implement, sometimes we call simulate, a distributed shared memory using message passing. And we want to do that so that our system, as usual, is fault tolerant, that tolerates failure of processes in the system. So here is our goal, an implementation or simulation such that the distributed systems looks to the clients of this system as a shared memory. And what are the concepts we are going to use here? We are going to see the shared memory as a set of object or memory locations, and each one of these memory locations we are going to call a register. In fact, these are objects, but special types of objects. Objects that we can only perform two operations on it. So a process can read a register, and a process can write to that register. And we have a set of these registers. Of course, we could have different kinds of shared objects. For example, shared queues instead of shared registers. But in this lecture, we will focus on shared registers with the two operations read and write. And that's what we call a shared memory. So we are in the asynchronous system model with n processes. These n processes communicate with message passing, and we want to implement shared memory. And as we know, processes are components or automata with state and transition as we used to in the previous lectures. So here is our system. And now we would like to implement a shared memory. So let us look to a single shared object, in this case shared register, and see how it looks like. So what we have is what we call read-write registers. And read-write registers has two operations. One is the read operation. This is the index of the register, R. So read R means the value of register XR was read, and it's read to be the value V. Write RV would mean it's a request to update register XR to the value V. So sometimes we are going to omit R or XR if we are just talking about a single register. So this XR will be omitted. It means that we are doing a specification with respect to one register. So here is our view. We have our distributed system here, and we would like this distributed system to give us the view of a shared memory. So this memory we are talking about is a distributed shared memory, and it will be a fault-tolerant distributed shared memory. We have a set of operations on a set of registers. So these are our registers. And we have the following operations. Write, a request to update the value of register XR to V, and a read, which will return the current value of the register. So in that context, these operations are not atomic. A process that requests to read a value will invoke a read operation, and a process that requests to write a value will invoke a write operation. So if we look to a write operation, in this case at process P1, so it does here an invocation of the write. It's a request now to write the value of 5. And here at this point, it gets a response. And the response says that the write is okay. It has been completed. And here is an invocation of a read operation, read a value. And here is the response. The response, in this case, we got back the value 0. So in a distributed setting, we are just looking to events that are invocations or responses. And as we said here, this figure shows that we just omit the register because we're talking about a single register. So the interface to our distributed shared memory faces an interface based on events. And these events are invocation events or response events. And we have the following, as you can see here. These are events related to a read. So this means that process PI invokes a read of register XR. And this says that we got a response event at process PI with the value V. So this means that the response of the read was the value V. Here is the corresponding events that describe a write operation. This is the invoke event, and this is the response event. So the first one is to invoke a write with value V to register XR, and this happens by process PI. And that's why we have this index here. It tells which process we are talking about. And write response, it's a response to the preceding write by this process. So let us now talk about basic assumptions in the context of shared memory. So as you can see, we did not, when we return a response, specify which operation was done. And why is that? Because we are actually assuming that processes are sequential. So in the whole lecture, processes are sequential. There are no pipelining of operations. And what this implies? It implies that each process will do invocation, followed by a response, followed by a next invocation, followed by a response. And these two together define one operation, either read or write. And these two together define another operation. So a process does one operation at a time. Of course, a process here could be a thread, so you can have multiple threads, but each thread is sequential. That's what we are saying here. The other thing we are assuming is that register values are of some type with some initial value. For example, registers could be of integer type, and these registers are initialized. So, for example, to some initial value, which is in this case 0.